Thanks everybody for joining us for today's webinar. This is part of our series we're doing on open source security. I'm Christian Capdeville, Product Marketing Manager at Anaconda, and I'm joined today by Hassam Mian, our Lead Sales Engineer. We work with companies from various industries, helping them to deploy Python and R in a secure and governed manner. And we wanted to use today's session to shed some light specifically on vulnerabilities and what to do with vulnerability data in order to leverage it to secure your pipeline. A quick overview of the agenda. Today we kind of wanted to give some background on the CVEs. We wanted to explain the life cycle of a CVE, where it comes from. We'll talk about some of the limitations of relying on that public data, and then how we can make this data actionable for us in securing our pipeline. And then we'll have some time at the end for questions as well. Now, if you joined us for our last webinar, you'll recognize this graph. What we're seeing in our Anaconda package download data is that enterprise use of open source software is increasing year over year. And with that increase in use of open source software, of course, comes an increase in vulnerabilities and exposures that we're seeing. In fact, we're seeing over 50 new CVEs each day. The rate at which new CVEs are coming onto the scene is triple what it was 5 years ago. So the problem is accelerating. And CVEs themselves can be really useful as we try to battle against software supply chain risk. But making effective use of them requires that we understand how a CVE comes to be and what limitations exist with regarding the public data. Otherwise, we'll have no way to discern between actual threats and false alarms. So a quick level set before I jump in with any more terms or acronyms. What is a CVE, first off? CVE is common vulnerabilities and exposures. So these are security flaws affecting software, and they create opportunities for cyber attacks. NIST is the National Institute of Standards and Technology. And really they're looking, among other things, to help businesses to better understand and manage and reduce their cybersecurity risk. What is the NVD, National Vulnerability Database? This is the U.S. government repository of vulnerability data. It's essentially a clearinghouse for CVE security information. And how about CVSS? This is Common Vulnerability Scoring System, which is NVD's framework for communicating how severe a vulnerability is. It goes from 0 to 10, and 10 represents the most critical. Great, so with that said, let's jump into the CVE lifecycle. How does a CVE come to be? Well, there's 6 primary steps, starting with discovery. So a person or organization can discover a vulnerability. They can report that vulnerability then to a CVE program participant, also known as a CVE numbering authority, or CNA. And that CNA will then go and request a unique ID, reserve the ID for purposes of working with it. And at the point that this CVE ID is reserved, the CVE is not yet publicly disclosed. It's not ready for public consumption yet. So the next steps are essentially gathering and submitting details about affected versions, vulnerability type, root cause, impact, public references, all kinds of stuff. And once the minimum required data elements are included, this will be published to the CVE list. And at that point, the CVE record is available for download and viewing by the public. So that's great. It's an awesome system for us to be able to surface threats in the open source ecosystem. But this flows into public data that a lot of organizations use to make remediation decisions to try to protect their pipeline. And something worth calling out is that there are some risks and inaccuracies that can present in this process. There's 2 primary places that this shows up in this life cycle. First off is discovery. The main thing here, the crux of the issue, is that anyone can discover and report a CVE. So it's not just package maintainers. And sometimes this can lead to inaccurate information making its way to the public databases. There's all kinds of examples of this, but a couple that we've listed here. You could have inaccurate package version bounds, or inaccuracy around which operating system is affected, or the package association sometimes is even wrong. It's perhaps actually a dependency and not the package itself, which can cause a lot of confusion. Another area that inaccuracies can crop up is in the submit phase. This is when we're gathering and submitting additional data around the vulnerability. And again, this is built upon the initial discovery information. So if you can think about kind of garbage in, garbage out, as soon as we start having issues, even at step 1 of the CVE lifecycle, well, we're going to have compounding issues as we go down the process. So in this case, you might have incorrect GitHub threads or third-party advisory references. It could be from, those advisories could be from unknown providers, or you could have inaccuracies in those references. The result of all of this is that you end up with a lot of noise, and it's hard to know which CVEs are important, which ones you should spend your time running down, which ones affect you. So there's other elements to this around severity, right? How do we prioritize which vulnerabilities we go after? How do we know how severe a vulnerability is? Well, one tool that does help with this is the Common Vulnerability Scoring System, or CVSS. It's a framework, as we mentioned earlier, for communicating the severity of a CVE, and generally you can use this table on the right as a guide for the kind of criticality or the severity of the vulnerabilities that are coming across in the public database. So for instance, if you have a severity score of 9 to 10, that's considered the most critical. So typically that's how you would prioritize remediation, at least as one input to your prioritization would be this CVSS, this vulnerability score. Now the NVD provides these CVSS scores as base scores, which represent the innate characteristics of each vulnerability, meaning it's not, of course, it's not customized to your pipeline. They can't tell you if you are using the vulnerable package or the vulnerable feature of the vulnerable package or anything like that. It's just how exploitable is it and what is the potential impact across all environments. Again, just to reiterate, this is all based on that publicly reported data in the life cycle that we just talked about, which is why curated CVEs or curated CVE data can be very helpful as a way to augment this basic public information. And to illustrate that a little further, like what are the limitations of CVSS? Well, one, as we mentioned, it primarily reflects the exploitability and the potential impact of a given vulnerability across all environments generally, but it doesn't really tell you about whether you're vulnerable or what you should do about it, or whether you're actually, whether you're actually using the feature that is vulnerable. So the CVSS really is intended only as one input to an organizational management process for vulnerabilities. And one additional kind of side note that I'm not sure how widely known this is, but if there are no details provided about a vulnerability, the NVD will actually default to assigning a score of 10, right? The highest possible score, the most critical. So in this case, you have another instance of kind of inaccuracies making their way into this public information where you might see a CVE or you might see a vulnerability that you think is highly critical, but it's actually only rated that way because it's missing information. So again, curation for this stuff is really key and very helpful in being able to make better decisions around what you do about these vulnerabilities. Sam talks to our enterprise clients pretty regularly about how to utilize this vulnerability data within their own vulnerability management processes. So Hassam, I'll go ahead and hand it off to you to walk us through some of the common scenarios and challenges that you've seen.
Thank you, Christian. Very helpful information. In our previous webinar, we discussed the rise of the CVs in this space. We also mentioned how there are roughly 53 new ones a day, and that the total number of CVEs has actually tripled in the past 6 years. This is a helpful view for us to understand the scale of the CVEs in this ecosystem, but it's also helpful to keep in mind what Christian was just mentioning, that these are simply reports and claims that anyone can submit with a wide variety of versions, various builds, and claims from reputable and non-reputable sources, right? So inherently there's a lot of noise baked in. So what does this realistically look like? There's roughly anywhere from 25 to 75% of false alarms in this space. So when looking at this graph, we really need to determine what does the real picture look like? Is it 25% like this, where just a small fraction are false alarms, and in fact, there's quite a few true vulnerabilities out there? Or is it closer to 75%, where in fact there's a significant amount of noise and there's only a few, right, that we really need to pay attention to. And so to further echo Christian, the public source and the work NIST and VD, the work they do is extremely important. But with the fact that anyone can submit these pieces of information, it really is upon us to determine what the noise is. And a great way to filter it out is via curated data designed specifically to help tackle this problem. We'll talk a little bit more about that in a later slide. But first, let's look at an example where an organization is not relying on any data, meaning no security scan, right? This was one scenario that we talked about in our last webinar, and this was the do nothing approach, right? And so, sure, they're using packages from major repositories. However, those components can still contain critical vulnerabilities or potential exploits that can be taken advantage of. In this example, an organization is simply allowing packages to be used. There are critical pipelines, model training jobs, and typically a development testing lifecycle of these types of initiatives take weeks or months. And so oftentimes these organizations either find out much later in the development phase, after months of development, that, hey, half of their development stack is actually riddled with vulnerabilities, or sometimes even the worst case scenario, which is, hey, that goes into production or it's in use, and there's an exploit that takes advantage of that vulnerability. And so not only are we talking about impact from a security threat perspective, but we're also talking about weeks and weeks of rework to rebuild these applications using a new package set. And so this is why many organizations have started to use security scanners or various CVE sources, right? And oftentimes their common security tools are often just reporting on public information. So let's talk about what happens when you rely on public information. In this example, by relying on public data, sure, packages 1 through 6 are blocked, and sure, any and all potential risk is being blocked out, but so are a lot of key packages that developers depend on, and importantly, functionality, new feature sets that developers need to innovate or be better at their job. And so not only are these packages limiting the flexibility and innovation, but the security admins are also drowning in alerts, as we see off on the left. And as a security admin, even if there is someone who's tasked with this, since many organizations don't have a dedicated team, right? Let's say security admin goes out and takes a look at each one of these CVEs. Let's see how they would have to resolve them manually. And so as an admin, you spend an hour or so looking into the first vulnerability. You discover that the upstream maintainer has already implemented a patch. So, your source essentially says this is a threat. You look upstream and you see this is actually something that's been taken care of, and you move on to the next one. After spending a couple of hours on the next one, you discover that, hey, there's actually a fix available and it's been implemented by Anaconda, right? And so you can get your packages directly from Anaconda, and we'll talk a little bit as to an example of something like this later. And so after all this work, right, essentially we come down to the consensus that, hey, there's only a handful in comparison to the overall alarm or alert list that an organization really has to pay attention to, right? And by simply going on a public approach, they're actually removing themselves from many packages that can totally be used. And so let's talk about the approach with curated data, right? And how, essentially the problems that we were just mentioning can be resolved fairly quickly, right? And so since you're removing the noise, you're allowed to focus on the items that truly matter, right? And so by having curated data, you're simply able to quickly understand which CVEs are absolutely CVEs in terms of, hey, there was some sort of claim, some sort of report, but it's narrowed down to the items that actually matter, the items that are truly a threat, right? Not the items that have been taken care of or the ones that NIST or, the reporter got incorrect. Now end users have access to the packages that they absolutely should have access to in order to develop and build the innovative things that they do for their organization. And security admins are actually now drowning a lot less in alerts, right? Since now they're only pointed to the ones that they need to focus on. And this scale is actually quite large, right? To get an idea of this, let's talk about PiPi, right? Which is a large repository of almost 400,000 projects. It's community driven, which means anyone can upload a package. And this also does increase the attack surface, right? Conda differentiates itself a little bit with the capability or the fact that it's a private repository. Anyone can't simply build a package and upload to it. Essentially Anaconda goes through the process of determining which packages get added into it. But again, we're talking about scale, right? So one of the most popular repositories in this ecosystem, PiPi, of 400,000 projects, right? And so there was a study done, and it was understood that around 46% of the packages within PiPi were vulnerable. So nearly half. And effectively 11% of the packages were critical, right? So the highest score that NIST NVD gives out. And so we just spoke about in the previous example where it could take anywhere from a few hours per CVE alert, right, to more complex ones taking days to manually verify, right? And just when we add the fact of the scale aspect to that element, right, that's a lot of man hours. And for many organizations, they simply don't have the bandwidth or can't keep up with this constant ecosystem. And as we mentioned, right, increasing ecosystem of vulnerabilities. And so this is why curation is really the knife that slices through all that noise. And in fact, I'd like to share an example of the impact of curation and how effective it is. Anaconda is used in all industries, and the one it's heavily used in is in finance, right? Not to our surprise, I'm sure, but like any large financial institutions, they take security very seriously. And in fact, they've deployed various security teams to hire in each part of the organization. Well, there was simply too much noise for one very large financial organization of ours, and they came to us with 975 flagged vulnerabilities, right? And this was actually flagged by a very common and popular scanning tool that's used by commercial-wide by all industries. And so this tool essentially flagged that, hey, there were 975 vulnerabilities. We don't know what to do about it. And it was simply too much for them to run through manually, right? And so they really needed to know which ones to pay attention to and needed our help. Well, we analyzed that list against our curated data, and we really just whittled it down to 4 critical vulnerabilities that they needed to focus on. And so effectively saving them hundreds of hours of manual reviews and due diligence and research, and effectively a 99% reduction in false alarms and alerts, right? So earlier we were just giving that boxed example, right, of those alerts. However, this is a real example of how we were able to speed this up for a very large financial institution, right? And so the key really is, hey, CVE data is really important, but this curation is also really key. Since there's so much noise in the ecosystem and in this risky space, we really need to understand very quickly which ones we need to pay attention to. And so how exactly does Anaconda curate this data, right? So at a high level, like Christian mentioned, there's that original source, that National Vulnerability Database, right? And so this is a National Vulnerability Database that aggregates up all types of vulnerabilities and exploits for all sorts of technological frameworks. And we take a few steps to essentially match up our databases, but we then really go into this curation process, right? Which we'll talk in a little bit more in the next slide. But based on this curation or review process, an output of results come out. And this output of results is essentially what we're calling our refined CVE data. And this refined set of CVE data is essentially quick flags that are added by Anaconda for you to quickly understand what the status of that package is when it comes to security. And so to drive a little bit deeper into that process, right, essentially we match up the CVE data with the packages into the repo, verify that those CVEs are actually components within our repo. And then we Right, and then this determine stage, this is where Anaconda staff members are actually hands-on keyboards, right? And they're going through and determining, hey, are these version bounds correct? Is this CVE appropriately associated to this package, or is it actually wrongly associated and should be categorized against some other package, right? Which builds does that affect, right? And based on the items that have been submitted or that are items that are references, right? Based on those trails and based on perhaps commits or other items that we're paying attention to, is that actually correct, or is there a section that we can go ahead and clear, or has this actually been taken care of and this is old data, right? And so this is really the value of that curation or that determining stage. And so based on that, that's where those flags or labels I mentioned come into play in the categorize stage, where these CVEs are then categorized or labeled with, hey, reported, meaning, hey, this is simply still being reported. This is the raw data. Perhaps it's still being curated, or this is fresh off the press. And then there's the clarity of active, cleared, mitigated, and disputed. Active essentially meaning, hey, vulnerabilities that have been identified that exist are absolutely labeled. And packages where Anaconda perhaps has applied a bug fix or code patch absolutely used to be affected, right? But no longer is, perhaps because of a new release or perhaps because of some backporting. And we'll share an example of that shortly. And then there's also a cleared status, which is, hey, after our research, we found that this package or this version or this build is actually not even applicable. So, this is noise essentially. So let's actually walk through a few examples of curation. I think each one of these is really, really important. So this first one was a CVE that was identified, and it was identified as having impacting Python 3.10 and before, right? However, after further due diligence, what we've also noted is while this statement is simply taking a backwards look, what we've noticed is that the fix or any changes or progress to move towards a fix hasn't actually been taken in by the core development team. And so for versions above this range as well, this is still potentially vulnerable, right? And this hasn't been fixed based on any research or due diligence that we've seen. So this is a good example of how, again, not only does the CVE just simply impact things previously, but there are also areas or nuances where looking forward is key as well. And what we've noticed is, it's still potentially being vulnerable as well. But the positive thing is we verified that there are no Anaconda components that are using that component, right? And so the CV in the middle is a good example of what happens when a package is incorrectly categorized. And so what we've discovered is this was incorrectly associated with a package. And in fact, what the result was, it was a dependency of its, right? And the dependency was a separate component altogether than Python itself, right? So in that example, what we've done is kind of cleared the original CVE because it was incorrectly attributing a CVE in the first place. And the last one is actually a really good example. This is an example where there's a certain package, ICU. It's a critical package that many, many other packages depend on. And so there are patches that were provided by the upstream maintainer for a certain version. However, because of how dependent this package is and how many other applications or packages rely on it, a lot of people use the historical versions of this package as well. And so in this instance, what Anaconda has done is taken that patch and actually backported it to previous versions of that package, right? And that's a great example of just how sure a fix is available, right? But there are scenarios where Anaconda may apply that fix retroactively, right, to versions or builds of a package that may differ than the public sources themselves. And so in that example, what we've done is mitigated that package. So we talked about vulnerability data and we talked about how powerful curation is on essentially filtering out the noise, right? So we understand how valuable this data is. Uh, what if we could use this data to perhaps stop that risk from entering the pipeline in the first place, right? Uh, or perhaps, understand when that risk comes up, right? Because we have some sort of system that stays on top of it. And so this is actually where automated security policies and governed channels come into play, right? The ability to essentially block vulnerable packages, the ability to automate your security policies, and the ability to essentially leverage curated CVE data coming from the builders themselves versus simply just relying on public data and then spending hours and hours of time and man hours uh, reviewing this yourself. And so that's where essentially that clarity comes in, that clarity of active, cleared, mitigated, and disputed, and how that clarity can be used to filter packages up front, but to also have an understanding as to when those statuses change on any packages that you potentially already have. And so there's ways to set this up. There's ways to set this up so you ensure that your organization is pulling from this and only this, that everyone is pulling from, the same sets of standards and security policies that your organization has applied. And this is offered as both a hosted and an on-prem option, just depending on kind of what your needs are, right? But the most important thing here is this is the item that essentially is that central point to manage the packages, manage what comes in based on that refined set of CVE data, and distribute it to wherever your Python workloads are. We've worked with customers in all industries with various diverse security and operational needs. We've helped implement open source security programs at all types of financial institutions, healthcare companies, manufacturers, and more. And so if you're ever curious, we can definitely help with yours as well. In fact, we're offering a couple of things for those folks that have attended the webinar. Thank you for your time again. One of those things is if you'd like to learn specifically more about security or some feature sets around security, you can contact us to learn more about the tooling or perhaps references to the tooling today. And you can also go through and book a security consultation where someone like myself is effectively going to sit down with you and understand what your needs are, what you're doing today from a security perspective, trying to understand kind of where you're headed and give you some best practice as to kind of what we've learned from other organizations so you don't make the same mistakes, or we can at least kind of help identify, the holes in the ground, so to speak, so you don't trip based on what we've heard from others. Thanks, everyone.